Hello, I'm Hannes, and I'm joined here in London by Ian and David. And we're here to talk about architecture, but I'm first going to let them introduce themselves to you.
Yeah, so I'm David Whitney, Director of Architecture for a company called NewDay out of London.
My name is Ian Cooper. I'm a Senior Principal Engineer at Just Eat Takeaway.
So you're both very involved with what we call architecture, but should we maybe start by defining what we mean when we juggle that term around throughout this conversation?
Well, isn't it really interesting that we both have very, very different job titles, but basically do the same job?
Yeah, I mean, that is interesting, right? I mean, and that's come about, that is an interesting topic because it's come about partially because there was a period where we don't need no stinking architects became the kind of mantra of agile and team empowerment. And I think a lot of it was this vision of the matrix with the architect, I say this with a beard, the bearded, grey-haired man.
Helping the stereotypes.
Exactly, yeah. Who sits in the room and dispenses, who controls everything, right? And I think that kind of gave architecture a bad name because it was seen as change control boards, constraints, stopping you doing things. And so we shifted terminology, right? So we started talking about staff plus engineering roles, etc. But I guess over time, and I think I've tried to test the definition and I've tried to almost resist the definition, but I do come back to the Grady Booch definition, which is that we, as software engineers, all software engineers do design all the time. If you're doing test-driven development, if you're doing contract first, you're doing design. Some of those design decisions are significant, and the usual metric for what their significance is either the cost to change them once they're made or the impact on how we reason about the system that we have. And that second part is often forgotten a little bit when we talk about that definition. But I think that tends to be true, this idea that there are architecturally significant design decisions that we do want to get right. And if we don't get them right, later on, we find ourselves struggling with the costs of the decisions that people previously made.
It's a wonderful language game, isn't it? There's no such thing as architects, but software definitely has architecture. So I guess they kind of are. It's funny because I have this weird personal connection to, unfortunately, Ian's job title, because in 2013, I worked with Just Eat. And that was the job title I made up for myself when I turned down the job that they offered me. Mm-hmm. I put the principal engineering role in there by virtue of the fact they needed something to call me when I was helping out. Yeah. And it's kind of ironic somehow that I've ended up lumbered with the architecture job title that I resisted.
Yeah, and I think you make an interesting point, though, about architecture inherently will exist.
Yeah.
Because I think that is also part of the concern that we get. So there's this notion we think about emergent architecture, which is you will have an architecture if you don't design one, and that architecture will be ad hoc built by people making a set of
organizational structure, right? It either happens to you or you.
Yeah,
and often driven by the situation as is today or the problems that you're facing today.
Yeah, and sometimes you can see it, right? If you go and if you're brought in and you're working with an existing system. It is like archaeology. You know how when archaeologists dig into the ground and there's basically layers, right? And you can kind of see that. And as people go, oh yeah, back then, so-and-so, yeah, he was really into this thing. And because nothing ever really gets removed.
I've compared it once to the way that a tree grows. You can look at the age rings of a tree trunk.
Yeah, right.
And you can date certain parts of the system by the practices that were applied in it.
Yeah.
So it's interesting. Like I like the nature analogies, but I often think of software more like living cities. Like a city like London, which is built upon generations of things because they're in perpetual motion.
Right.
Nothing ever changes. And I think nothing ever changes. Everything always changes, but the large scale form of the place often remains the same. And I think the thing about systems, like I've always been a great believer in emergent architecture, but I think a lot of people mistake the idea of emergent architecture for something that thoughtlessly just happens. Mm-hmm. And like, yes, if you get it wrong.
Yeah, essentially, I mean, that's an interesting metaphor. I don't want to extend metaphors too far, but if you compare London to New York was organized with a grid system. So someone sat down and thought about how we're going to organize the streets And hey, we want to make a very deliberate decision about how we think that works. Whereas London is just like, streets happened. Yeah.
There's a riverbank and we start building.
Yeah. And the streets wind in curious ways that, may make no sense anymore. All right.
And probably what makes for a charming city is necessarily
it's not very efficient. All right. Yeah. So, I prefer to talk to nowadays more about this idea of sustainable architecture. So what I tend to contrast it with it is this, right? So we always tend to use metaphors, right, with architecture, which I think is an interesting topic in itself. But I think about the practice of farming, right? And there's two ways of doing farming broadly. There's kind of slash and burn, where effectively I just go in and I cut down stuff and I exhaust the land by using it. And then I kind of go, I can't really do anything here anymore. I've exhausted the land. I'm going to have to move on. And you have to effectively build a new system or buy something else in. And a lot of places that don't think about architecture, they're very much doing slash and burn. Or there's a kind of sustainable.
Is that where companies face themselves with, we need to rewrite the system or we need to re-architect it completely? It's like, we've hit a wall.
And it may be a valid choice though, right? In certain sectors, the lifetime of your system in some of the kind of digital marketing, et cetera, is very, very short. And so it's fine. Yeah. Slash and burn may be a perfectly valid choice in that context.
Mm-hmm.
And then sustainable, where effectively you say, okay, I need to essentially keep producing software, keep changing it over time as my business evolves. So I'm going to need to think about either fertilizer or letting land lie fallow. So you're going to have to keep reinvesting in the design because you build a system on day one and here's your business and the two match, right? And over time, we assume the business is going to change. Business pivot, they see new opportunities, they see ways of working with stuff. And then effectively, for a sustainable architecture to work, you're going to have to change the architecture to reflect that new business need, right? With a slash and burn one, you just add bits on until the whole edifice falls over. But with a sustainable architecture, you need to say, okay, I need to change and adapt my architecture to reflect the new reality that I am actually building.
But that's a very conscious process, isn't it?
It is, yeah. But I think the problem is businesses don't sit down and go, which one of these choices am I making? And I think it is a choice, but I think you need to explicitly say, we are making this choice. And I know that if I choose slash and burn, I am faced with the big rewrite or acquisition.
Right? Yeah.
So it's interesting that, we opened up thinking about what architecture is. And, so what my job, I think, probably is, in the literal sense, is what I imagine an executive producer on a film to do. Carefully helping what my trade skills are and not that thing.
Yeah.
And I think, the difficulty with architecture as a profession is often what makes you really, really good at it. And I guess my traditional belief is like coming from, I'm a programmer. I perceive myself to be a programmer that is very, very sensitive to design, and design scales out and scales out and scales out until it becomes architecture and software. Really, when you go from kind of micro level design to macro design, and really it's just that thing. But the actual work often is helping people not back themselves into corners, really. And because of this like constant perpetual motion, right? It's, I have this core belief that I don't think you can predict the future. You're probably going to get it wrong. What you can do when you're designing software is you can know that if you can know where the fault boundaries are inside your application, you can know what things could flex and what things couldn't flex. I read this throwaway piece, don't like invoking big tech very often, but it was some Jeff Bezos fluff piece. And I took one thing away from it, which is he had this idea like there are two types of decisions, right? There's type A or type B, or type 1 or type 2 decisions. And the game is making type 1 decisions, things that you can trivially undo cheaply and quickly and not spending any time on them, while really, really taking the time on the type 2 decisions that are expensive or time consuming to unmake. And that always kind of stuck in the back of my head. And, I constantly think that most of my actual job is encouraging technical leads and heads off to think in terms of trade-offs. What if this happens? What if this happens? What if this happens? I don't care if the answer is we're screwed, but at least know which bits are broken when that happens, so we can flag them and we can make knowing choices.
And I think we all know Barry, right? And his take on we put an architecture out there, and if we bring it in contact with the real world, it's always going to get first pulling on it.
And
it won't survive.
Any design fails its first encounter with reality. This is just like, and this is kind of the heart of everything we ever learned about incremental development, TDD workflows, and fast feedback loops is all about saying, hey, the job of a software person is to come up with some kind of hypothetical mental model and then render it into reality in text in a way that seemingly ergonomically represents the thing that you have in your head in a way that other people can understand it, right? So it's core communication form. And communication is deliberately vague and lossy and all this kind of stuff. And I think, Barry's angle, and I don't want to try and muller his books by reducing them down to a single paragraph, is, well, actually, the job of traditional philosophy is thinking about thinking. Well, software architecture is kind of thinking about modeling. They're kind of the same thing. And actually, all of these previous thousands of year old conversations show the internal contradictions of the failures of modeling reality, because reality is so complicated, it often fails to be modeled and you cannot predict it. So all you can really do is work out where systems stress and where stress is applied and what changes that occurs. I'm sure I've ruined that. I hope he doesn't watch this.
No,
but that's the sense.
I think he mostly talks about like if I invent like a virtual stressor to my system, which part of my design would survive?
It's about simulating that process.
Like which change? And if I then invent a whole bunch of them, like there's always different parts of your system that are gonna have to get replaced. Reasoning about that and then coming up with a system that is good at dealing with the most predictable stresses
good enough.
Is good enough for now, but at least you've done the thinking exercise of what is going to remain of my system when it comes in contact with reality.
Yeah, so I step back a bit because I know that actually, so Barry, in the way he uses the technique, uses this bit like this. So the bit I used to default to a lot was attribute-based architecture. I mean, formerly ATAM, architecture technology assessment method, which comes out of Carnegie Mellon. So a lot of really good architecture work comes out of Carnegie Mellon University from architecture styles onwards. And really, the short version of that is we say, what are the quality attributes? So there are various lists of different quality attributes, but things like how modifiable is it, how performant is it, how usable is it? All right. What we say is we can define what quality attributes we need from the software, which is generally used to be thought of as our non-functional requirements. And then we say in order to test any given design, we can test it against effectively those quality attributes and say, does it meet the quality attributes we've set? And we may be lucky and we can come up with a design that goes bang on.
It meets everything. Yeah, of course.
But typically what happens is we end up with a trade-off where we say, okay, I can get a design that does 6 of these, but not 3 of these. So those are my risks. So I need to manage those risks by figuring out what will I do to cope with the fact that I've got these kind of weak points. What Barry does is he starts a bit earlier.
Yeah.
And he says, if I think about the simplest possible design that you could have, like, a web server and a database, and then I think about how that might be then pressured to change over time. We were saying earlier, right? It's the problem can change over time. How can I simulate that? And what he's saying is it's typically, which is what David was saying earlier, we're very bad at predicting what those changes are likely to be.
Yes.
So you can just effectively randomize that, right? I mean, it's a good use of LLM, right? Come up with 20 random things.
Well, that's the thing that separates, like, when I look at architects and what makes it very hard to probably even define the role of an architect. If you look at the people who are really successful at it, they're the people who kind of instinctively find out, like, this is the design I'm going to need for now and probably the foreseeable future.
So
for a while.
Yeah, so Barry's had this conversation, right? And one of the things he said is what he was asked to do was figure out how to give people that understanding. And said the problem is that the traditional way of doing it is effectively give you a whole load of roles in architecture and you basically break all of people's companies. And at the end of it, baptized by fire, you now have your instinct for what's going on. And the thing is, can you formalize that? Which is effectively where, so it's residuality theory for the camera. It's basically what we're talking about. And residuality theory comes from this idea of, can I simulate that? And one of his observations is this notion of attractors, which kind of says, to some extent, it doesn't matter what scenarios I generate. A whole cluster, some scenarios will cluster around a given actual type of change to the system. So you can create a scenario like Godzilla stomps my data center. And that's fine because really what you're actually pushing towards is this kind of model. So we were actually, I don't
any natural disaster that's gonna have.
Yeah. I mean, we were using it at work, at Adjusted Takeaway to think about some delivery aspects, right? and somebody came up with a scenario which was there are bases on Mars and we want to basically deliver takeaways to
What you do is,
all right. But the interesting thing that's generated
a
for
latency conversation, and
but also about what kind of vehicles, right? So does our software understand what type of vehicles? And you can see that actually there are a whole lot of real world scenarios that effectively have the same attractor, like we decide to use trucks or etc. So that's the thing what he's getting at, is the bit that random simulation, it turns out, is in a way more useful, because us trying really hard to think about where the business will genuinely go is difficult. But it turns out you can actually just use random to stress the system and then figure out what will your architecture survive.
What you just said about the people you see as most successful are people that kind of grow an innate sense of the thing. I think my job actually is finding words to describe my instincts. Like when I back really, really far away from like what I do with my teams and how I give them guidance and the structure and the org stuff, I think mostly I'm trying to give people language so we can develop a shared mental model to talk about software in a way that everybody in the room understands, so that, and you know, we talk about trade-offs. Like the big thing for me over the past 2 or 3 years has been having technical leads articulate trade-offs to me. Because, you know, when I joined this organization, they had a very traditionalist view of architecture, which was, you know, something that I didn't agree much with. And I had a lot of technical leads who would come to me for blessing and anointment. And I'm like, you think this is my job? It's not my job. I'm here to make you good at this so that we can scale, because I am one person and I have a small team of other people that can help me do this, right? And I think, you know, and maybe it represents my natural bias in that I like language. I think language is very important to me. But the same thing I saw in Barry's books and material was he was doing a very good job of finding language for things that we have intuited over time and have often been the subtext to process, where, you know, architecture is often in its role as custodian, and the ivory tower thing has been like, here's a bunch of processes that drive these effects. Whereas my view on it is really like you give people a language and they can talk about them and those effects happen.
So it's interesting, because then that gets us back to the thing we talked about earlier, right? Which is trying to help people understand which decisions need to get surfaced because there are architecture.
What are the trade-offs?
Because sometimes you might opt for a local optima. And the problem is we can't do that once. So in one side of one team, that might be okay, because you're all communicating with each other, right? Architecture, I think, is often a property of bit of scale. So effectively, as soon as I've got 2 teams, right? So an easy way of understanding that problem is this, right? You're on your team and you decide, what are we going to use to communicate with our system? And you go, oh, I really like gRPC. I really want to use gRPC. So you build your stuff with gRPC. David's team, another team, goes, what are we going to use to basically communicate with the system? And David goes, oh, I really like about German architecture, so we should use Kafka, right? You got a problem now, right? You want to send David messages about gRPC and he wants to receive them by Kafka. Someone has to sit above that and say, we need to make a decision about how these two things are going to work together. So someone has to engage in that more systems level of thinking. Yeah. Whereas for you, there may be a local optima and using something you know well and is an established technology. Yeah. The problem is, and you may go, but I would be faster if I used gRPC. I know nothing about Kafka. I've never written Kafka in my life, right? So you might go, Kafka's not the choice for me, Ian. Why would I use Kafka? I can't understand it. But we may have to sit at a high level and go, okay, we need to reason about what the organization needs and decide, actually, is gRPC better suited? Is Kafka better suited? And that's the problem, because I do expect you and your team early on in your career to definitely make rational choices about, not simplifying, not overcomplicating, using things you know. Someone sometimes occasionally has to be the person that sits above that and go, but for the whole...
This is best for us all.
Yeah.
And it's both looking at which communication patterns will make sense in the system. And at some points, you might find yourself fighting Conway's Law because you have teams designing parts of the system and they communicate in certain ways. And
so one of the really interesting challenges in this area that I struggle with a lot, I struggle with, I think my team struggle with, is everybody really wants and loves the idea of standardization everywhere. Like when you come from engineering teams, they love the idea of it and they all want to write the one true standard, right?
Yeah.
The one true standard. And unfortunately, the way that often manifests is all the people that early on in their careers engage in design often want what traditional architecture looked like. hey, we should have some meetings and we'll do some coordination and we'll think about the specs and we'll do this. And I constantly have to push back against them and say, I understand your urge here, but what you want to be is in the middle of a room, and we have, 50, 55 teams. If your job is to be in the room for all 55 of those people, 10 minutes a day, your entire job for the rest of your career is stamping decisions. That's not the work, right? And actually the learning, and I think I probably went through that as well, when I was younger. The work is to work out how you can not be in the room.
So I think the thing that we're edging around a little bit, because actually interesting, and we'll come back to that, we're just basically bringing in a lot more standardization. And the reason I think that we have to think about this is scale, right? So different things happen at different scales.
Yeah.
If I am 12 people in a room and a startup,
you can do anything.
I can do anything. We're just directly communicating with each other the whole time, right? Mm-hmm. And I know exactly what you're doing because you just told me basically, in the morning coffee break, what I'm looking at, right? And that's great. And that's why people love working with startups, because effectively we can move really fast, we can bounce ideas off each other, and then we succeed. The worst thing that can happen to us basically actually is software.
Oh God, you're now live.
Is we succeed and actually customers start using our software and it's like, the fun's gone now. And then we have to get into this model of being a kind of scale up, right? So we still need to move fast because the pressure of all these people arriving is making us fast. But now the number of people is increasing dramatically, and people are arriving who have absolutely no idea how we have all the decisions. When we're a team of 12, the hard fought, decisions where we all reach consensus about how we're going to build stuff, and now just thrown out the window because somebody else has come in. He's been here 4 weeks and he's been asked to build something new, and he's going to do it the way he's doing. So you go through this whole transition where we've got to figure out how do we do architecture there, right? Or if we do architecture there, right? We got to figure out what is appropriate at that point. And then that will stabilize out. And now we have lots of customers. They have begun to depend on us. Their business has begun to depend on us. We're now in a kind of enterprise mode where essentially breaking all our customers is worse than not releasing features at the same cadence. So we're in a different world in terms of how we think about architecture and decisions that we're making. Because one of the points that I occasionally make is if I've got 12 developers and I've got 300 developers and I've got 1,500 developers, it's a very different approach to how we work. Right.
And people need different things from you at that scale. Yeah. And I think that's one of the big lessons I had to learn is, I'd say my foible as someone responsible for air quotes architecture is I think like a programmer too much. Like legit. I think it's a great benefit I have because I can go to the mat and understand what the work is. But at the same time, I often think, oh God, I wouldn't want these things imposed upon me. Right?
No, right, yeah.
And what I actually had to learn, and this was only a handful of years ago really, is that teams want more constraints than I give them sometimes.
Yeah.
And actually, I often took the don't ask me for rules because you'll get rules and then what I say goes.
So I think one of the...
Sometimes they need them. I think they need them to be free.
It's very simple, which is actually, there's a whole lot of bunch of people for who, it's a job.
Yeah.
They want to come in at 9 and want to go home at 5 and they want to succeed at it and they want you to tell them explicitly what you want.
That's cool.
And there are a lot of people who have opinions, right? Who believe strongly that one way or the other is better.
Like your life of misery.
Yeah. But actually what you need to do is
both.
Yeah.
You need both.
Yeah.
To succeed, you do both.
Just to communicate, you can short circuit the process a little bit, which is I need to communicate with people with opinions. Right? And we need to reach consensus. Yeah. The other people will follow, but they want us to reach consensus. They don't want us to effectively be constantly fighting with each other because that's just, I don't know what I'm supposed to be doing.
Yeah,
Please just make a decision and tell me, right? So they want you to reach consensus. You kind of have to cluster those people. And I think part of the thing is, as we were saying, on the scale of the organization, when there's 12 people, maybe there's 2 or 3 of you are driving everything. Maybe all 12 of you are, but you can reach consensus, right? When there's 300 of you, you've got to figure out, effectively, that's when you start to get the kind of staff plus engineering model, right? Yeah. Who are these people that effectively we need to communicate with, who we have to agree how we're going to build stuff, that effectively generate the culture that we build stuff with? And that is part of the problem, is figuring out
who will pull along all those people.
So, yeah.
Was that more like, tell me what to do mentality?
So here's the interesting thing. The way that I've attempted to solve that, or we collectively as an organization have attempted to solve it at my current gig, is all those people line into me. So they pop out of the engineering org and they're still attached to areas and teams and look over things. But ultimately it's like, okay, we will have a consistent dialogue. And then at least when we are public about the things that we're fighting about, we're on the same page. And
Yeah.
And I guess the thing about scale is that probably works at 50 teams. Probably doesn't work at 200 or like a world scale org that you have to subdivide.
So what we've tried to do is adopt the process from Andrew Hartman Law, which effectively he calls architecture advice forum, and internally we tend to call it an architecture hub. And the idea is you propose an idea, it's a architecture decision record in his technology, but people use RFC for it.
Mm-hmm.
And you say, this is how we want to build something or use that. And then what happens is in that advice forum is everyone who's impacted, everyone who's kind of an expert in that area, and they give you feedback.
Yeah. Right.
And the idea is to, rather than a change control board, what we're saying is you have to record that feedback. You have to essentially say, this is the feedback I received.
Well, we either accept it or we reject it or we acknowledge it.
But you have to formally reject it if you reject it. And it means that you have to motivate your decision.
And so the interesting thing it turns out about that, right, is I may hold a very strong opinion until I'm asked to basically sign on the line to say, I genuinely believe my opinion rather than David's, right? I look at David in the face with his tons of experience or something, and I say, I'm going to have to formally say, David knows nothing and I'm
about this thing,
right? And that's actually quite clarifying.
It's not often that black and white now, is it? I've never practiced architecture at the scale of the organizations that you're in, but I've been in growing organizations. And what I found is basically a combination of things that you both have been saying. It's like at some point you have to find a way to articulate your gut feeling. It's not just like, I believe that this would be the right decision. You also have to dig deep and figure out why your gut is telling you like, this is the direction that, at the same time as accepting other people's opinions and then having a meaningful conversation from that angle as well, and not just dismissing that. Because if that is the role you play, you become that ivory tower architect that is a single point of failure.
It's malleable, right? So you get enough opinions, we tend to basically cluster towards ones that are viable. I don't tend to see out of that process too often unviable opinions.
Yes.
I may see opinions that I disagree with because I think they're expensive, hard to maintain, and more difficult. Mm-hmm. Typically what would happen though is, because also organizations have to be learning organizations, right? Mm-hmm. So I need those people to learn. So it may be actually, I know where this will end up. But maybe it's okay, because the way I learned where this will end up is you did it, you made the mistake, right? Made that mistake. And so maybe it's okay for, we record all the opinions, they start down that road and they go, actually, this is looking like the thing that we said we didn't believe would happen.
Yeah.
Mm-hmm. And software's malleable enough, often we can roll that back.
It also depends what area of your system you're doing this experiment in, right?
Exactly that. And it's difficult for people because I think the older you get, the more gentle you become around unmaking decisions you've made, right? And I think when you're very, very young, you make a decision and you fall in love with it. And, you see it as your work. You see the work as a proxy for you. And then you build a few systems. And you're like, well, this will probably change in 5 years anyway. So, if I'm wrong, I'm wrong. It's fine. Like, we can get things wrong.
But I do think there are some things where effectively you have to say no. And that's why we have some standards, right? Yeah. So a sufficient scale. It doesn't really, when there are 12 of you, right? You have a discussion about, I don't know, what messaging middleware we're going to use or whatever.
Right. Yeah, make some big bets.
Yeah. And
but if you get 7 of those in there, it's a mess.
Right, exactly. So what happens is that every team makes that decision. It's now expensive, it's incompatible, we're spending a lot of time just effectively worrying about the interconnection. So at some point, somebody's going to have to make the big decision that says, we use Kafka for basically streaming, and we're using RabbitMQ for
queues and topics.
Here are the tools.
Here are the tools.
Enjoy.
Just go and use those. I don't want you to keep making that decision, right? And someone may say, but I think we should be using that. You're completely wrong.
Don't care.
But at some point, we have to reach a decision. And ultimately, I would say at some point, we have to evaluate the trade-offs, figure out one of them is clearly basically better on that kind of quality attribute model. If it comes down to judgment call, someone has to make that judgment call, right? And but ultimately, some of those decisions, there is not, you can't tolerate all decisions because they're not compatible with each other.
I always run with this throwaway sentence that like great software is like great sci-fi. It's internally consistent. So the outer edges kind of have to look uniform enough that people can interact with them. Once you're inside the box, you're inside the box. Right. And ironically, I really care about what's inside the box. but on a different cadence, in a different kind of mental model, different mode of operation.
So one of my good examples of this, right, is there's two things I talk about, right, a lot: messaging and a test-driven development, right?
Right.
So messaging, I quite often have to be a bit strict, because you have to,
because it's the outside of the box.
Yeah. Test-driven development, the teams know what I think about test-driven development, right? And I'm quite happy to explain to them how I think test-driven development should be done. But for a given team, provided they effectively have tests and there's test coverage, I am not going to tell your team
how they should be writing tests.
You can come and ask me for advice, and I will explain to you my methodology. But what you actually do as a team is your team.
Yeah, it's so funny. I have that conversation really often with the more enthusiastic tech leads I have, who often they'll come to me and they'll be like, "Oh, David, I know you've been like a lifelong advocate for, like, I've seen all this stuff," and I'm just like, "Well, do you know what I'm going to say?" So I don't. You're not really here for anything other than validation. Yes, I'm like, "Oh, but you know, can't you make it a policy that everyone's got like 100% test coverage?" I'm like, "I'd love to, but it wouldn't solve any problem."
No.
Like, it's not going to affect anything about the way you write your software because you're doing it already. And me saying that is just going to make those people feel bad and feel like they're in conflict with me. There is no victory here.
And the other danger is you get cargo cult behaviors.
Of course.
Right. So people imagine that if I follow the ritual, I get the outcome. And that never really works, right? Demanding 100% test coverage. The problem with that is it's hitting a number which you can gain,
of course,
without understanding what was that supposed to have driven. So I think it's like interesting when you look at Accelerates, Nicola Fosgreen and a few others, basically that took some evidence and said, evidence-based is what things work in terms of organizations, right? One of the things in there is they basically say, okay, continuous delivery definitely works. It's practice we see work in high-performing organizations that are all doing continuous delivery. But I often think about that and think, but the point is, in order to achieve that, you had to fix all these other things.
Yeah.
Really, that is just effectively the turning on continuous delivery without fixing all the things you need to fix.
It's a terrible idea.
It's a terrible idea.
You
need to avoid the cargo cult behavior. You need to say...
You have to first get to the point where you can confidently manually deliver, consistently every single time. It's like, I would feel confident pushing the button to deploy right now. Because otherwise, if you switch it on...
Exactly that.
And that journey takes time. Yeah. Like, for a lot of organizations, that's impossible to even do within the course of a year.
Right? Yeah. You can say our goal is to achieve continuous delivery by this date or whatever, and then basically line up all the things that you need to achieve in order to do that, right?
But that often forces changes on your software design. It forces changes in your culture.
Yeah.
People have to change their behavior, which is often the hardest part.
So here's the thing, right? So we've been talking about during the big scale system design sense mostly. I often think a lot of the conversations about architecture actually miss the software architecture in it. The localized API level, and I don't mean HTTP APIs, I mean the actual ergonomics of designing abstractions in code. And I think maybe over the last 10 years, so much thought was put into the I don't want to invoke its name, but the big old monolith microservice pendulum swing game.
Yes.
That people are always thinking about big blocks. And actually what I've seen over time, and I would say this is kind of uniform, is the quality of a lot of software I've seen has gone down in the last decade, because I think that that keen eye for what does good design look like inside of the context of an application has started to melt away. And I think there's a couple of things that have been on the top of my mind here. I think we saw like the proliferation of very, very common patterns. So people really lent on the, hey, here's one correct answer for this. Like MVC basically took over the web, then function-oriented programming did, right? So like web is that thing. But then you get into the applications and people don't have that keen sense of what ergonomics looks like anymore. And I think we don't really teach it. And, a lot of this stuff kind of gets swept up into the software craftsmanship movement a little bit, but I think that kind of has started to age out of the audience that are now doing a lot of the implementation.
I think the interesting thing about the artisanship movement, right, or craftsmanship, if we want to use that term, right, is I think it started really well, which was this, I kind of really think it started things like pragmatic programmer, etc., which is, hey, at the low level, we should be masters of our practice of writing programs and code and using our tools, and that kind of mastery was seen as great. And
it's probably even older than that. It's probably like the structured programming kind of papers and things like originally.
And I don't think actually necessarily this idea of at some point in your career, you essentially you can might want to lean on things like patterns, etc. But because you're buying in experienced designers' wisdom by saying, okay, here's a way of explaining how you solve this kind of problem, right? And that's kind of more junior and probably the sort of mid-level and junior developer, right? Is really at that level of saying, I want to take an off-the-shelf solution to my problem. I've got this problem. And then you get to the kind of more senior level where effectively you should be able to direct which solution, which patterns to use, or even to say, actually, there isn't, a good approach. You want to basically understand the things underlying, and you get to staff plus, you should be the principles. The problem I think we got into was patterns became more like
gold standard, gilded, canonized.
You must always build a clean architecture. You must always build, and that was never what was intended, right? What was intended is effectively here is design wisdom that is encapsulated in.
Well, software patterns were observed things. Yeah, they were here are things that we've seen emerge repeatedly. Let's write them down and give them a name.
And if you have this problem, maybe that.
And the thing, it depends, doesn't make for a good video because it doesn't get the clicks.
Right. So,
but it's very much that. It's like we might need to do one thing over here and then another thing over there because they're two different problems, part of the same solution.
I got a funny story. So I went to see. There's a really good Tim Burton exhibition on at the moment about all of his works. There are a couple of things. I love the movies of Tim Burton. I'm a weirdo. I didn't realize at the time, and it's obvious, he trained as an animator, a classic illustrator. And the thing that really struck me when I went to see Tim Burton's exhibitions is they had all of his university coursework. And Tim Burton's university coursework is absolutely textbook regular form. Perfectly observed regular studies and anatomical diagrams and like really, really textbook kind of I'm learning a trade craft in animation. Yeah. And Tim Burton is famous for completely subverting regular form. All his iconic style absolutely throws out all of that stuff. And I stood there and looked at it and it kind of what did it make me think about software? I'm that boring. What it made me think is all of the best libraries and frameworks and localized design choices that got popular mostly were a subversion of regular form, but done by people who really, really understood what regular form was about. And I think that's kind of how do patterns really emerge? How do you find the shape of an API or a thing? And, I was thinking about this, MVC is really popular because it was a good way to model interaction-based server-side web apps.
Really?
When you actually think about what it is, though, well, it abuses the use of classes in most frameworks, and classes are meant to be bags of functions and data traditionally. So it takes like an OO thing and totally bastardizes it into something else, but actually it's really idiomatic. And I think there's lots of these subtle examples of manipulating and subverting form in great software design that, because a lot of programmers don't have the language of design on the tip of their minds when they're thinking about it, you kind of don't see it for that thing that it is in the moment, but you see pieces of design fundamentally in the very traditional sense. Design is form that expresses intent, and people find this form in software that's so beautiful and expressive. And I don't think it's a lost art. I think it's just a part of software architecture that we've not quite managed to get the language around yet. And I feel like I've been reaching at it over the last couple of years. I wrote talks about like intentional design and all this kind of stuff, and it's all this same feeling that I have, that there's kind of an inherent beauty and mastery in the work that isn't like it's not craftsmanship. It's not the carpentry analogy that people see. It's design. Mm. And I don't know, I'm hoping maybe the next 10 years of architecture for me is going to be more interesting in that space. Started to use some of that language about form.
So I think what's interesting, right, for me and what you're saying is there is this slight tension between, in some cases, seeing the emergent properties of something, in some cases, reaching something off the shelf. So one of the things that I find occasionally, right, if I'm writing some code. So right now, for the open source project I work on, Brighter, which is a kind of messaging framework, I'm thinking of planning on adding some support for kind of workflows. But what I did early on was just write some tests and some code.
What should this look like?
Yeah. And once I had more of a handle on what is the problem, what am I trying to solve? What are the things that I'm seeing emerge? Yeah. The advice in a sense of how other people solve these problems becomes more meaningful to you.
Yeah.
Because now I can understand.
You've contextualized the thing.
Why did they do that? Oh, because they're trying to solve this problem.
Yeah.
Okay. So actually, part of the problem I think is the problem with patterns is if you apply pattern right at the beginning of the process, you don't really understand where it's
you don't get the understanding, right?
If you journey towards it and you go, okay, now I understand why someone would have done this.
Yeah.
Because that's going to be the solution. All right.
Mm-hmm.
And so there's a little bit of you have to learn on this curve.
It's Chesterton's fence, isn't it? Like, unless you understand why someone does this thing, don't you dare not do it.
Yeah.
But once you learn why it's been done, well, what you kind of have to do is you have to reach the same goals, maybe using a different aesthetic perspective, and the problem doesn't go away. You still have to solve the same problems that they solved in that way.
But it does imply to us, right, that when we talk about architecture, all right, that when we talk about people learning architecture, that the danger with being prescriptive, right, is the danger of that learning thing, right?
Cut them off from...
Yeah, and what you're really looking for, to some extent, is to say, here are solutions, architectural styles is commonly the kind of word you use. Don't start with the architectural style. Don't start with CQRS or hexagonal or clean or whatever it is that you're basically thinking of using. Don't start there. Start with your problem. Start trying to resolve your problem and then say, oh, actually at this pain point, what I could do is adopt this, right? So you start and you're writing your tests and you think, actually, it's going to be really helpful for me to separate out the domain from the infrastructure. It's complicated enough. It's not a simple transaction script problem. I've reached a point of complexity that's going to be painful. I need to separate this. How am I going to do it? And you may go, oh, yeah, ports and adapters actually solves that problem. I can see where they built that, right?
Yeah.
Okay, so I will transition at this point to some ports and adapters model because that's going to help me achieve my goal, which is to separate these.
Have a nicely isolated domain and make that very testable,
right?
Without worrying too much about the infrastructure is going to come around.
It's very different to reach for that, because you need it because you had the problem.
Yes.
Than to say, to enforce as a template standard, everybody's going to write everything to our template.
And then everything looks absurd because it looks over-designed.
And then you have an API that is basically a bunch of CRUD operations without too much logic in it. And then that just gets in the way. It doesn't add anything.
Right. And you get a huge backlash. You get developers going onto social media saying,
there's too much ceremony.
I hate this architecture. It's rubbish. Why am I being forced to do it? Right. And the problem is you're being forced to do it. A problem didn't need it.
Yes.
But now you've devalued the solution. Yeah. You've devalued the solution because you think the solution is terrible. The answer is you didn't really have the problem and the solution was built for.
And I think what that is taking that thing where the form is meant to telegraph the intent of the thing. That's where what you see in a problem space is its architecture, not the problem. The weight of the architecture overwhelms the actual problems that you're solving. I used to play a game called Sea of Thieves quite a lot, and I used to watch the devlogs. And they had a phrase that I thought was quite good. It was a game design thing, but they always used to say, tools, not rules. Their game was all about adding a tool, not a rule for the players. And I think design is kind of similar. Like give people tools to reach for when they find themselves in places where they need to solve certain categories of problems, rather than say, okay, well, here are the 10 problems that you're going to suffer, because they don't get that understanding.
But I also think it also speaks slightly to the danger of to go back to the first when we came into the conversation, right? Why is the architect from the Matrix, why is that seen as an antipath? And I think that problem of people templating and mandating that every team must use clean architecture, all right? That's why it's seen as ivory tower, because effectively the team goes, but my problem's nothing like this, but you've made me conform.
Here's the 10 commandments.
To this rule, right? And that's where architecture gets a bad name. Whereas if architecture said, hey, we have lots of style advice we can help you with when you hit these problems, and it's more of a pull thing, which is, I think, where this conversational style of architecture comes from, right? It's kind of like the team goes, oh, it was really valuable to engage with the principal and staff engineers because they showed us how to simplify
this pain
thing that we were already experiencing, right? Whereas I think it's very arrogant to sit at the center and say, all of your problems are best solved by using clean architecture. Because it's kind of like, I'm not close enough. At a large enough organization, I'm definitely not close enough to your problem to really be able to make that judgment.
Do you feel that in order to give teams that authority to make those decisions, that you need to be more rigid on the communication patterns that are allowed to use between them?
So I think that if you have a larger organization which divided your world into various subsystems, right, let's call it for them without choosing particular words, you're going to find that some of those architectural systems, like how do things talk to each other, you're going to have
a protocol or standard always
exists, right? You can allow more freedom inside those little islands. And then what you're doing more is this model of saying, here we can give you advice, where effectively we say, these are things you might want to reach for, but we don't want to be prescriptive because we want you to figure out what's best for you. And also inside that area, in theory, the problem space is much more malleable.
And they're different. Yeah. Maybe the different technology and some patterns work better in different places.
Sure. And I often say the contract is the really important thing. If I've got an API, etc., that's rigid, that's hard to change. And the impact of you wanting to change that ripples out to other teams. But your details, that's for your team.
I'm almost totally disinterested in the fact that we need rigidity and boundaries between systems. It's like, of course we do, because these are computers. And like, if we do not have this, then the systems will integrate. Like having the thing is the touch point, but it's not. I feel like that's like a non-revelatory point. Is like, okay, well, the whole world basically has messaging or HTTP. There's probably a few, like, yes, you can have small decisions over what style of messaging or when would you choose one over the other? What are the resilience characteristics and the asynchronicity that you can put into your system? But I feel like there's maybe 10 big decisions there, and they're mostly easy to make. You pick one or two and you're done. What you do at that point is the interesting bit, right? Because they're hard to get, like the semantics are difficult challenges to get right. Once you've got them, you've got them. And that's that's the good bit about protocols, right? We love this stuff. But
it's like pick your messaging
but do I think that is what design really is? That's like, I don't know, saying the fact that all buildings have structural support is the essence of what a building is. And they are all super valuable things, right? Like, and I think maybe my perspective is a bit more creative minded rather than industrial programming minded, which I think is actually where me and Ian, where whenever we disagree, it's always the difference between those two things.
So I think what we're getting down to there is a question of scale, right? It's the difference between like town planning, right? And where we're saying I need to run the roads, I need to run the infrastructure, I need to run all the things you need into this little block where you're going to build your houses. That's one kind of architecture, right? There's another kind of architecture which says, how the houses in my, how am I arranging the block for am I going for capacity and building high? And there's another level of architecture which kind of says, hey, what is my house?
How do the humans exist in this size? Yeah.
And you even get down probably to where we're really at the team level is more like the kind of interior design thing, right? What do I want the style of my house to be so that I find it comfortable and habitable, right? And I think that the question is often, when we talk about architecture, the problem is people don't necessarily qualify which one of those levels they're currently operating at.
Because for the teams, they are living in that house. They're working in that particular code base that is part of the bigger city.
But one of the interesting things as a casual observation is we're both programmers. And I've always held that belief that by understanding the work, I can be better at making decisions that affect the people that are doing the work because they live inside these systems. And I think, I don't know if I've met great architects that fundamentally don't come from a programming background or haven't lived the work.
Yeah.
And maybe some of them exist. I truly don't know.
I think you can get into, because it also depends, I think there's a slightly separate
space. It's like the EA space.
The architecture space, which is more about
business problem domain modeling.
Use software to solve our problems. I think we are slightly more in solutions-y, systems-y space, which says, what is an effective design to solve your problems?
I think there's just there's a dissonance, right? I've certainly met a lot of bad people. Oh, bad people is the wrong expression. People that have made choices unsympathetic to the realities of operating software. There are many, many categories of system design where you can draw a very, very nice diagram because it makes the information easy to understand. But when you actually think about what that manifests as systems, if you literally translate that diagram into moving parts, you built a nightmare of fault boundaries and failure and all sorts of things.
I think it goes back to, the old school idea of, are you a general that goes to the front, eats and sleeps with the troops, understands what their direct experience is like? Or are you a general that lives in headquarters, basically where Batman's
you've got a map that you move a few pieces,
right? Because, exactly. You look at that map and you don't really understand what it means to move to that hill.
Right? The map is not the territory.
Right, exactly. And I think that's important. You need to be able to, at times, go to the front, spend some time with the troops, understand what the problem is, because actually it may turn out that the real problems that need solving are very different from the ones that they seem to be back in headquarters when you're staring at the map.
Understanding and empathy.
So that's the answer.
Communicating to people.
So that's the answer to the opening question of what is architecture? What's the job? Cool. So talk about architecture.
But actually I think that's interesting, the point about understanding and empathy, because the point that we often talk about, right, is one of the problems is that, and I think I see this in the kind of staff plus individual contributor room, is that people assume that rising into kind of staff from principal roles really means no one gets to tell me what to do anymore. All right. And I'm a more senior. So I'm a senior developer, but it turns out some people are effectively keep influencing the decisions I'm making. I must climb higher until the point where I am completely autonomous, right? But really what actually it means is you suddenly start to have to deal with the people problems in building software, not in a managerial kind of context of my job is to basically think about the management of the resources, their application,
social
problem.
It's not the performance reviews of the people.
Right. It's more about how do people build software.
Yeah. I think one of the things that I've often found myself saying when people have come and asked me for designs for things is, you really don't want me to do that, because ultimately if I design this, the best you're going to get is the thing I can think up. And you have more information than I do. I can make a call, but you got to help me help you better.
Yeah.
And that, I think, is the crux in the change in architecture from like traditional TOGAF, ivory tower kind of stuff to what I think works today for real people.
Well, I mean, so at a GOTO, I was talking to Emily Bark, and she was talking about the idea of believing that we need engineering coaching more as a role, right? And I think that there's definitely a crossover what we're talking about here with that idea, the idea that generally a lot of what we're trying to do is coach engineers on how to make decisions better based on a bigger picture or a longer history of understanding,
and then occasionally make decisions when they have three competing ones.
Yeah.
Basically.
Yeah.
Tiebreak.
And a lot of that is really, people are making decisions all the time. The problem becomes if we make a bottleneck to those decisions via architecture, what we need to help them do to improve the architecture is not become a bottleneck, but to help them make better decisions in the first place. Right? And I often characterize this as, I can't be in the room if at an organization of a scale of 1,500, 5,000, whatever. When you get to really big engineering decision making, right, you can't be in every room. So what you have to do is you have to create a culture, which means that when you're not in the room, they will make the decision you wanted them to make. And that is about coaching, about education, about giving them the value experience, saying to them, okay, here are patterns, but basically don't apply them blindly. So it's giving them the benefit of that experience such that they can make good decisions, right? And so it's not you making the decisions, it's them making the decisions, but then they're making the good ones.
So ultimately, it's all a people problem again.
It's always a people problem. Right?
Everything's a people problem.
It is hard to realize that. And I think
computers do exactly what you say they will do all the time. Everything is communication, everything in the world.
And I think I resisted that for a long time. As someone who, slightly more introverted and enjoyed the fact that the computer would leap and jump to my command and I didn't need to do anything with it. The idea that I couldn't scale that to be everything, I can just basically give it an instruction set and it will do what I want.
The difference between the job and the work.
Yeah, very much true.
I think that's a great way to end this conversation by concluding that massaging people to do the things that we
make everybody feel good.
Yeah.
Or at least feel vindicated.
Yeah.
And let them run into their own walls.
Yeah. I'd also understand why they want to do something a certain way and what are they reaching for? All right. And how can you help them understand a different way of doing something that might be more successful for them?
Awesome.
And also that you can be wrong, right? You could be wrong, and they may actually have a smarter idea than you.
I've been wrong before.
I've been quite often wrong, right?
I got out the other end.
Being wrong is not a problem, because being wrong generates insights. Far more than anything else, being wrong generates insights, certainly. Yeah. But to be prepared to have those conversations with people.
Awesome. Thank you.
Thanks.
Thank you so much.